So, hello everyone, and welcome to this weekly session that we conduct, Ask AuxEn Anything. And you know that this is an online platform for civil structural engineers to interact with us and ask their doubts or queries related to RCC steel design concepts or any project that they are doing or construction site related issue queries. So, this is the 71st episode, and let us begin by taking the queries that have been asked for this week. So I'll take the queries from the Google form and email, followed by the queries from our live audience. So let me share my screen. So the first question for this week is has been asked by engineer Ravi Ranjan. He's from Ranchi and he's a working professional. So he's saying I am having trouble after I run analysis like modal participation ratios, diaphragm, mode check, and why my beams always demand big sizes. So, what is the question over here? What is the question? I'm not clear what is the question over here. This is just a comment that you have made. What is the trouble you are facing? And before making such statements that your beam sizes are large or anything like that, understand what is happening and why or what is the reason for the beam sizes that you are getting, whatever you are getting. So what is the reason first? Try to understand that and put your question over here. I am not clear that what is the query that has been asked. So if you are attending this session live, just put your query in a detailed manner, and I am moving ahead for the time being. So next question is from engineer Arun. He is from he's a working professional, and he has asked what is the deciding criteria to choose moment connection and choose moment connection or pin connection. Is it a fixed rule that we provide moment connection about major axis and always provide moment connection of beam flange with column flange? No, so fixed rule means it first of all it will depend on your structural assumptions or structural configuration that you want to come up with. So it will depend on structural configuration. For example, if you want to create a moment resisting frame system, if you want to create a moment resisting frame, then you ought to have, or it is necessary that you have a moment connection. If you see, let's say if you want to have a simple system that I'm showing you an elevational view, this is your column, and you have just a beam, and this is my column, and let's say it is only subjected to gravity loads alone. Now even if you have a shear connection, there will be no problem as to stability of the system if it is subjected only to gravity loads. But if there is a chance that it will be subjected to lateral loads also, this system on its own is not a stable system if these if the beam column joints are shear connection only. So then either you need to introduce a moment connection over here to ensure lateral stability, or else you will have to add bracings in this system. So let's say if you have come up with a moment frame, and generally we call it as a portal frame in that case. So if you have decided that I want to create a moment connection over here, rigid connection over here, then accordingly you will have to design this connection for the expected moments and forces and shears. Okay, that is one point. Let's say if you had some other system, if you had an eccentric braced frame system, okay, then it is a choice of the designer whether they want to have this connection as a moment connection or a shear connection or pin connection. So if you have added eccentric braced frames for lateral loads, even a shear connection I am calling a pinned connection as a shear connection right now. Okay. So then you are allowed to have either a shear connection or a moment connection as per your choice and as per what is possible. Now, if you want to control lateral sways, then it is good. It is suggested to have moment connections. If lateral sways are controlled by some other elements like braced frames or bracings, then you can go for pin connection also. Next part of your question is that if you have an I section, I'm showing you in the plan view. This is my column, let's say, and this is my beam. So then this type of connection you can develop as a rigid connection or a moment connection where the column flange and beam flange are connected together. So it is easier to develop a moment connection over here because the arrangement allows you to have a rigid connection made. So I can develop rigid connections over here by either by providing end plates, so that is called as the extended end plate connection, or then there are other options also by providing some T junctions or whatever. Like this also it's possible, or by adding stiffeners and bolts are placed like this. And then there is a design procedure for that, adding stiffeners at the back also. So when you connect the beam flange to column flange in an I section column, this can be created as a moment connection. But if you want to join your beam flange from this side, then it is not, I mean, it's very, very difficult to create a moment connection over here when the beam flange is connected to column web. Why? Because the column web has a very low moment of capacity out of its plane. So it's very difficult to have a rigid connection or a moment connection here. Then there are other options. Then there are other jugaad works that you may have to take plate from here, and then come up with some sort of rigid connection, but it's too complicated. So generally, if you are using I-shaped columns, uh, only about one direction you can create moment connections. About the other direction, it is slightly complicated. So depending on all these aspects, you have to think. Depending on your system, you have to decide that which connection you would want to provide as a moment connection and where you would like to have as a shear connection. So sometimes if you want to have moment connections in both directions, then we avoid using I-shaped columns, and then we try to go for a plus shaped column like this, made up of built up eyes or built up plates. So I'm showing you the plan view over here. So if I have this type of a column shape, then I can create moment connection in both directions. Okay. So then this strategy is adopted. All right. Okay. So this was Engineer Arun with his query. Now we move on to the next question. And next question has been asked by Engineer Vinayak. He's from Bangalore. And what he is saying, cantilever rafter support to column with pin connection. Is it stable structure? Sir can speak about stability of the structure and how force will transfer rafter to column. I have shared the image in WhatsApp. So he has shared one image in WhatsApp. Two images he has shared. So this is one of the images he has shared, and one more image he has shared, which is this. So he's asking about the stability of this system. Here it seems to be a pinned structure, pinned section. Although from this image it's not very clear what exactly. Yeah, this seems to be a pinned like connection. But there are no other angles to this image available. It would have been better if we could have had some other angles also to this image, other photos from other views, other directions also. This does not look like a image clicked by a structural engineer, because if this image was clicked by a structural engineer, they would have added photos from other angles also, isn't it? So the query is about the stability of the structure. So I don't know, unless I do not see the images from other directions. I'm not sure how or what is happening. I'm not sure what is this. Is this a structural element or is this a non-structural element? That also I'm not quite sure right now. But what it seems to be that uh, this seems to be a tension member, because there's a turnbuckle arrangement that has been kept over here. So this turnbuckle arrangement is to pre-tension this uh, pre-tension this anchor. Okay, so this has been kept under pre-tensioning, so that if this tries to go down, okay, if this system tries to rotate like this in the gravity direction, this will pull it down through tension force. But what about the load reversal? If there was a load reversal that was to happen, then this system will come under compression. This turnbuckle will come under compression. Under compression, it will not be stable. So maybe this is the element that they have added, which is taking the forces right till the ground. It's not clear from this image right now. In cases of load reversal, maybe this is what they have thought of. So this image is not very clear to discuss what sort of structural system have they come up with. Is there any alternative way of doing cantilever roof with less quantity? Unless we do not have specific uh, structure, I cannot answer this, because there can be different ways possible for different. There can be different ways possible for different structural configuration. So unless we have a structural configuration, it is difficult to answer this. The next query is uh, next query has been asked by engineer Sujoy Patra. He is a working professional from Bangalore. So he is asking, we assign we assign diaphragm to transfer lateral loads. No, this statement is wrong. This is an incorrect statement. You do not assign diaphragms to transfer lateral loads. Lateral loads will anyway be transferred if you have modeled a slab and that slab is connecting your beams and columns. Lateral load will anyway get transferred, even if you place diaphragm assignment or don't place or don't assign any diaphragm. Lateral loads gets transferred anyway. So this is an incorrect statement, first of all. Okay. What is the functionality of semi-rigid and rigid diaphragm? So simple answer is that if you provide rigid diaphragms, it will have no displacements, or it will have no deformation about this axis. I mean, how should I say? In the plane of the lateral load application, it will have no deformations if you assign it as a rigid diaphragm. Okay. If you do not assign any rigid diaphragm, or if you give semi-rigid diaphragm assignments, then it will have a degree of freedom that is available in the plane of the diaphragm or in the plane of slab also. So when do we assign rigid diaphragm? Suppose you want to uh, cut down on analysis time and you want quicker results, okay, and you know that there are going to be negligible in plane deformations in this slab, then you can assign a rigid diaphragm to your slab or to your slab element, okay. If if you are not sure about the way in which this slab is going to behave, let's say if there was a large opening in this slab, or if there was a cutout in this slab, or if the aspect ratio was like this where you are not sure how the slab will behave in plane, then you can assign a semi-rigid diaphragm and see the analysis results and try and understand what is happening, or how the uh, or how the slab is behaving basically, okay. But in most of the cases where we have RCC slabs, which are, let's say, around 150 thick, aspect ratio is less than 3, and where you do not have any large openings, your slabs behave, or your slabs will have negligible in plane deformations, and you could safely assume them as rigid diaphragms. This problem of semi rigid rigid comes generally where you have wooden floorings or where you have steel decks. Generally, if you see in Western American countries or in America, Canada, Europe, etc., many of their floor constructions happen in timber. So over there, it's a problem that your slabs are not, or your floor panels are not rigid enough. So over there, they have this problem of in-plane deformations possible also, and that's why they try to keep it as semi-rigid to see how the diaphragm is behaving. In the Indian context, where we have RCC slabs, most of the times it will have negligible in-plane deformations, and it will behave as a rigid diaphragm. Okay, so the functionality of semi-rigid rigid is just to, I would say, quicken your analysis time, because if you are sure that there are no in-plane deformations possible, it is easier to give the rigid diaphragm assignment and proceed ahead. But these days, your computers are so fast that even with semi-rigid assignments, it does not take much of an additional time. Okay, so you might as well give a semi-rigid assignment also. If your diaphragms are such that you need to provide collector elements or chord elements, if you have slabs where you need to look into the uh, chords and collectors also, then you need to give it as a semi-rigid, because if you give it as a rigid assignment, then it will not give you any chord or collector forces. So then you should give it as a semi-rigid assignment. Okay, all right. Standard size of meshing for slab and shear wall. There is no standard size as such. It depends on your project geometry, project size, etc. Usually, I like to keep it at around zero point 0.5 meters for slab. Okay, zero point 0.5 mesh size for slab. For walls, it will depend. Again, for walls, I like to keep it as zero point 0.5 meter in plan view. So if this is my plan view, I like to divide it into 0.5 meter units, and across the floor height, I do not divide it at any floor levels. So no need to divide it along the floor levels. So for example, if this is floor level 3, floor level 2, floor level 1, and ground floor, no need to further mesh it along the floor levels. But in the plan view, again, around 0.5 meter is a good size to have. Again, it will depend on the uh, project size, but usually speaking, zero point 0.5 is a good size to have. Okay, yes. Next question is from, next query is From engineer Hiren Desai. He is a working professional from Surat. He is asking what is pattern loading in ETABS, how it works in analysis and design, whether it gives same results when we choose envelope load combination or separate load combination, does it give same results when pattern loading has been considered in above both the case. What does this last point mean? I am not clear. What is see, pattern loading means, let's say this is your plan view, and this is your plan view, and this was your framing. All these are your beam lines, these black things are your beams, and all these green are your columns. Okay, and you had a similar sort of, I would say, grid spacings, and your structure was such that there are possibilities where the entire structure is not going to be loaded uh, with live load at the same time, and it may happen that, let's say, this portion of your slab gets loaded and this portion of your slab gets loaded, but the other portions remain empty. That might happen. Or let's say these portions get loaded and this entire middle thing remains empty. Or there might be a situation where, let's say, the entire slab panel gets loaded but these two get empty, remain empty. So if this is the situation where, let's say, you have similar grid spacings in your plan view and there are possibilities of patch loading, I would say, where not the entire structure gets loaded together but it gets loaded in patches. So for example, if this was a storage warehouse plan, okay, in such cases it happens that some portions get loaded and some other remain empty. And if the live load magnitudes as compared to dead load magnitudes are significantly higher, if your live load magnitudes are higher as compared to your general dead loads, usually what happens in our normal structures is that the dead load is usually larger than the live load for which we design, isn't it? Because dead load includes the self weight, it includes the wall loads, it includes the finish loads, and live load just includes the weight of, let's say, the human occupancy or weight of people usually. So in many of the structures that we do, the live load magnitudes are lesser than the dead load magnitudes. But if you have a case where live load magnitudes are higher than the dead load magnitudes or almost comparable, if you have similar grid distances in your floor plan, and if there is a possibility of patch loading, there some areas might get loaded, other areas may remain vacant. In those cases, you should go for pattern loading, because that pattern loading may give you moment imbalances in the columns, and those moment imbalances in the columns will mean that your reinforcement percentage will be governed by those moment imbalances, because we know that in column design, more than the axial loads that your columns are subjected to, moment imbalances uh, are governing or critical, isn't it? So if I ask you this query, that if I were to load all these four panels with the same loading, and I was talking about this column, and these grid spacings were more or less similar, will there be any unbalanced moment in this column? Tell me. Quick yes, no. I am talking only about gravity loads right now. Will there be any uh, moment imbalance in the column? Will the column be subjected to any moments? So answer is no, because there are loads from all the sides. Okay, loads from all the sides, so everywhere the loading is getting balanced and there is no net movement that is transferred to this column. So if you were to, let's say, load the entire slab with the same load everywhere, what will happen? That The internal columns, you won't see any net moments. If there are no net moments in the internal columns, you might design your columns for only axial loads and you would see that there are no net moments. So you would just design your columns for axial loads and give the reinforcement percentage for it. But that might turn to be an unsafe design if there is a situation where, let's say, only this part of the slab is getting loaded. So if I have a case where only this part of the slab gets loaded, then these columns are going to be subjected to moment imbalances, which you had not considered in your design. So that is the reason why we go for pattern loading. Okay. How it works in analysis design, I hope I have explained it. So there are options in ETABS. Earlier, these pattern loading options were there in STAD only, but now those options are in ETABS also. So you could see the process for application of these pattern loads. I have forgotten right now how pattern load is to be applied, but you could just see the process either on YouTube or some video, or just go to some help menu, and I'm sure you will find the process. Or you could of course do it by manual methods, where you could just load this, let's say, and give it live load 1. Okay, keep all other panels empty. Then maybe you could load this and you could give live load 2 as the name. Over here you could give live load 3 and so on for each panel. And then you could come up with combinations that, let's say, there is a possibility that these 3 panels get loaded together. So you might add, let's say, live load 1. This was, let's say, 6 and 9. So you could add live load 1 plus live load 6 plus live load 9 in one combination, and add it with your other combinations. Then if there is a possibility that, let's say, this is 7, if there's a possibility that this part of your slab may get loaded, you might make a combination with live load 1 plus live load 2 plus live load 3 plus live load 7, and then put it in the appropriate combination. So this type of work you could do, or you could rely on the ETABS and safe process to apply the pattern loads. Okay, so this is how you need to understand the pattern loading. And then once you make all these possible combinations, you can put them in an envelope if you want to get the worst results. Okay, so have all the possible combinations with pattern loadings made, and then uh, put it in the load envelope, or put it in the envelope. Okay. All right. So this was his query. He has a follow up. Which value for pattern load factor should be given and its importance? Again, it depends on what type of loadings are expected, what is the configuration type, or what is the structural system. On that basis, you should come up with a pattern load factor. Generally, pattern loads should not have any factors. I think you are talking about the live load reduction factor over here, but pattern load should not be given any factor. Okay. Yes. So this was his query. There were some follow-up queries from engineer Sujoy. One more thing, he is asking in relation to the earlier question. One more thing, is there any change if I model wall up to top and model in one floor and then replicate it? No, you should not model your wall up to top. Always model walls from floor to floor and then replicate it. You might create errors, although if you model using the plan view option in ETABS, there will be no error. But to avoid any errors, it is always better to go in the plan view, create your walls at every story, or use the replicate option. Okay, to avoid committing unforeseen errors. And Sujoy is asking, is there any requirement to provide separate meshing for both cases? Which both case are you asking about? That's not clear. Yeah, that's not clear which both cases you're talking about. Okay, moving on with the next question. Next query is from Engineer Pratik Malke, he is from Maharashtra, Dhule. He is an independent consultant. He has put a query in Marathi, written in English, written in Roman, and he is writing it in Marathi. मला RCC and steel design firm सुरू करायची आहे. डिझाईन कन्सल्टन्सी पूर्ण आली पाहिजे. त्यात स्टील अँड RCC. तुम्ही मला गाईड करणार का? मला तुमचे PEB चे लेक्चर्स चांगले कळते आणि तुम्ही इन डिटेल विथ पिक्चर चांगले एक्सप्लेन करता आणि मी डिझाईन इंडस्ट्री कशी सुरू करू त्याचे मला सपोर्ट पाहिजे. सो ही इज बेसिकली आस्किंग दॅट ही वॉन्ट्स टू स्टार्ट हिज ओन design consultancy firm, and for that he wants to learn steel and RCC design, and he's saying that will you guide me for it. He has taken our PEB course which he is finding it useful, and he's asking that how to start a design consultancy firm. So I would say that first work for 3 to 4 years under or with some senior person or with some experienced person. Work for at least 3 to 4 years with them, and only then think about starting your consultancy. Okay, before that do not before that don't start a design consultancy unless you have 3 to 4 years of experience. And if it comes to guidance, my suggestion would be that you should do our basic courses. That will help you a lot with understanding the basic principles and the basic design processes to be followed for steel and RCC structures. Okay, so first work for 3 to 4 years under someone with someone else, and then try to start on your own. So this was the query. These were the queries from the Google form, and we do not have any queries on email. So now we will take the queries from live audience. Let me just check on email also. No questions on email. Then there are some follow-up questions over here. Mr. Sujoy is asking, previous model all along or replicate? As I say, previous model all along or replicate, should I give separate meshing values for both? No, so if you are giving some slab value of let's say 0.5 over here for meshing, I would suggest for walls also you give 0.5 itself, so that when auto meshes are generated, the slab mesh and wall mesh coincide. So try to have similar mesh values. Mr. Hiren is asking a follow-up query. There is a value to be given for pattern live load factor in design preference dialog box. Okay, I didn't know that. To my mind, I would say that give a value. Don't give any factor value if you are taking pattern live loads, because as I told you, you are trying to simulate a condition where some portions of your structure will be subjected to live loads, others won't be. So do not take any factor value, and just take a value of 1. Okay. All right. Anything else? So we have a question on WhatsApp also. What is the query? Okay, there is no query attached, so I'm not taking this question. There was these images shared by engineer Sri Shell on WhatsApp, but he has not put any questions, just images. So I'm not sure what the question is. All right, moving ahead. Let's now look at the YouTube comments, live comments. So engineer Hiren Desai is asking if I have a single pile below the column for single story, I have modeled it as a pin support. Yes, that's fine because pile cap, a single call. Let's say you have a column and you have a pile cap and you have a pile over here. Generally, it would not be able to take any moments, so it's okay to model it as a pin support. It gives horizontal reaction. Soil consultant has given different horizontal capacity for different horizontal displacement. Which value is permissible? Usually for lateral load capacities, 5 mm is considered as the lateral displacement value at which they give the working load capacity in the lateral direction. So usually it is 5 mm. Okay, but I'm not sure what your geotechnical person has given. So unless I'm able to see the report, I am unable to comment. Okay, but usually it is 5 mm if you refer to IS 2911 part 4. If you see the testing protocols, they give it as 5 mm. Okay, then next question is from engineer Aditya Mehra. When dynamic analysis in steel structures, it depends on your structure, and if it requires response spectrum analysis and equivalent lateral force procedure is not enough, if the equivalent lateral force procedure or ESM, what we call it as, if that is not sufficient, because let's say the masses or stiffnesses are varying along the height, along the floor levels. If that is the case, or if you are having some irregularities, whether they are horizontal or vertical, under those cases, you may have to go for response spectrum analysis, and your uh, equivalent lateral force or equivalent static method may not be sufficient. Okay, so yeah, so that is the answer. Then existing slab 200 mm put on steel column having 15 tons load. How to check it is safe? You check for punching. Existing slab 200 mm put on steel column having 15-ton load. You are saying column has been put on slab, or I'm not sure what your question is. Has the slab been put on column or column has been put on slab? In either cases, check for punching. Usually, punching is checked at d by 2 distance from face of support. So try to check over there. Okay. Yes. Anything else? So, any other query anyone wants to ask? We have taken all the queries from the live audience. Column put on slab. Yeah, so check for punching at d by 2 distance and check for one-way shears also, and check in the normal manner in which we do. Okay, by finding out the perimeter and then finding out the checking the shear stresses at critical perimeter. Okay, anything else? Okay, so Mr. Shrishal has put one query and now he has put an image also. Oh, sorry, images he had put, he has now put a question also. So this is his image that he has put, and then he has provided this. This is one image he has provided. This is he is calling it as case A, and then there is a case B, and then the question is whether I need to release the beam or not. Out of case A and case B, which modeling is preferable? So his configuration was something like this. I think he has drawn a reverse section A. His section A should have been like this. Yeah, because this seems to be the bigger thing over here, and this seems to be the wall over here. This is my understanding from what I can see. These yellow things, I'm not sure what they are because I cannot zoom into it and see what's happening. So this thing, uh, again, it looks. I'm not sure what is happening. This is the slab over here. So this size, I'm not pretty certain what is the size, but let's say assuming that this is some sort of a beam and this is again some sort of a thick RCC element, but this connection, I think they will not be able to develop the reinforcements and all those things. So looking at the configuration and with my limited understanding of what I have seen in this image, this type of modeling looks more appropriate. From what I could understand in the image, looks more appropriate because here both the elements have been released, both the ends have been released when it is getting connected with that big thing over here and with the wall on this side. So I think this case B looks more appropriate from the limited understanding I could get. Okay. Yeah. So case B modeling is the one which looks better. Mr. Hiren is asking, is there any specific reason to specify 5 only? He's asking about that pile capacity. So IS 2911 part 4 gives these protocols for testing. And remember, this is the working capacity. So this is the for at working load. To find out the working load, they will find out the ultimate capacity, and to get the ultimate capacity they will test your pile and see at what lateral load you are getting deflection of 5 and then I think they do a half of it. I think they do a half of it to get the working capacity of the pile. Now why it is only 5 why not 50 why not 10 why not 8 I don't know. Okay, maybe beyond that it will start to affect the structural system or structural behavior. Maybe that's why they have come up with 5 but why and how this specific 5 value and why not any other value, I don't know. You need to ask the codal committee. Yes, thank you. Mr. Sanjeet Kumar is asking, in the transmission tower, dynamic analysis required or not? So again, it depends, as I told you, on the configuration you are having. Uh, but in dynamic, in your towers, because it has a long height and because it is quite flexible structure, I would suggest you to go for dynamic analysis. I would suggest to go for response spectrum. Okay. Yes. Anything else? Any other query? So I think no other question from our audience. So I'll just wait for a couple of minutes. So every week, as you know, that we come live on Sunday, and where we take up your live queries. So throughout the week, you can continue putting your queries in the Google form, and once every week when we meet, we take up your live questions. Okay, so the link for the Google form remains the same. You just need to put in the queries over here, and we take them up during the Sundays when we meet. Yes, Bhushan sir is asking composite deck slab design as per IS 11384 shear stud numbers. Is it different from Eurocode? Sir, I do not know it as of now because I am yet to properly study the IS 11384 and I have not studied the Eurocode. So, unable to answer your query at this point in time. Mr. Hiren Desai is asking, is there, as there is no relation with dia of pile, okay, that 5 thing. So as I told you, it is related to the serviceability aspect, and uh, therefore you are limiting your displacement levels to 5 for finding out the working load capacity. Okay, I think there is some relation that up to 600 dia there is a certain protocol, and beyond 600 dia there is a slightly different protocol if I remember correctly. You could go to 2911 part 4. Yes, any other question? Okay, so I think no further queries. Yeah, so the link for the Google form remains the same. Kindly take my last comment. I already took this comment. I think you are not there. I already answered this question. I said that there is no relation with pile dia, but there is some protocol which says that beyond 600 pile dia, there is, I think, some different protocol given for testing, and less than 600 dia, I think there is some different protocol. But why it is tied up to 5 because maybe beyond that, the lateral displacement in piles may cause some serviceability and stability issues. So that's why maybe they have limited that uh, protocol for testing to 5 Okay. Yes, please. So this is the link for the Google form, and you could put your queries over here. And in case if you want to connect with us directly on WhatsApp, you can click on this link, and where is it? You can click on this link to connect with us directly on WhatsApp. So yeah, this is the link. So I think that's all for this session then. There are no further queries from the live audience for this episode. So thank you everyone for joining today's session. We'll meet you again next weekend where we will take further queries. Till then, have a good time and have a good week ahead. Thank you. Bye bye.